Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your mathematics tutor and an instructor of mathematics at the University of Liberia. In my today's lecture, I will be looking at variable separable under differential equation. So variable separable is one method of solving differential equation, finding the general solution of a differential equation. Whenever you notice that you are capable of separating the variables, or like you are capable of separating all of the expressions in x on one side of the equation and all of the expressions in y on the other side of the equations, then you can use variable separable to find the general solution by integrating both sides of the equation. So we've been solving a lot of other problems in our previous lessons. We want to solve the 12th problem now, the 12th problem in this lesson. So let's see how we find the general solution of this differential equation. E raised to the power y plus 1 cos of x dx plus e raised to the power y sine of x dy. So remember, our goal is to ensure that all of the terms, all of the expressions with x be on one side of the equation and the others be on another side of the equation. So whatever side you want to put x or y, it doesn't matter. So I will prefer putting y on the left hand side so that if it's possible to solve for y at the end of the solution, so I can easily solve for y on the left and just have it like the conventional style where you have a function in the form y equals to x, x, y, z, right? So now this is the y, so I will maintain the y right here, e raised to the power y sine of x dy. And then this term, I send it across the equal sign, so it becomes negative e raised to the power y plus of 1, e raised to the power y plus 1 cos of x dx. So now this is the x, so every expression here must be in x. Now in here it's in y because e raised to the power y, so I must divide both sides by e raised to the power y plus 1, and not just e raised to the power y, but this entire factor, and then divided by e raised to the power y plus 1. Likewise with this sine of x, this is y, so I must divide both sides by sine of x and then sine of x. So this cancel this one, sine of x cancel this, so you have e raised to the power y dy all over e raised to the power y plus 1. So on this side you have all y, so we can integrate this side. Now minus, for this now we have cos of x all over sine of x dx. Likewise, it is in x, so we can now integrate. And we're going to apply the u substitution right here, thereby saying let u equals to e raised to the power y plus 1, such that if we differentiate this e raised to the power y plus 1, we get e raised to the power y dx. So this is now the u is equal to e raised to the power y dy. That is the derivative of this equation. And then we move on this side, we can say let v equals to sine of x, because if we differentiate sine of x, we get cos of x. So we have the v equals to cos of x dx. So we can now replace, we have the integral of this numerator is just du, and then this is just u equals negative. So this is also dv, and then divided by v. So if we integrate now, we have the ln of u equals negative the ln of v plus some arbitrary constant c. So we can rewrite this c as ln of c, which still remains the same as a constant. So we have the ln of u now. U is e raised to the power y plus 1. So it's e raised to the power y plus 1 equals, so we can take ln of c first minus ln of v now is, this v is sine of x. So we have the ln of e raised to the power y plus 1 equals, Now the ln of c times minus ln of this expression is just equal to the ln of c all over sine of x. What's the next thing we need to do is that we need to bring in this property. We know that e raised to the ln of x is equal to x. So if we say e raised to this expression, which is ln of e raised to y plus 1, if we do the same on the side, e raised to c all over sine of x, so e raised to ln of this expression is just equals to e raised to y plus 1 equals, is also equals to c all over sine of x. So if I send this one across, I will have e raised to y equals to c all over sine of x plus 1. So what I can do now is also I can take the ln on both sides, because I know that the ln of e raised to y is just equal to y. So I want to solve for y. So if I take the ln on this side and I take the ln on the other side plus 1, I can just have y now to be equal to ln of, now I can find the LCD for the two of them, it doesn't matter, sine of x all over, let's say sine of x downward, then we have sine of x into sine of x is just 1 times c is c plus what goes into sine of x is just sine of x times 1 is sine of x. So we just have this to be our general solution. So remember I told you the general solution is not a fixed solution. It can be of different forms because of the way people may want to reduce their general solution in different ways. Your instructor may want to require you of different answer. Probably your instructor may not want you to reach as far as this point. Your instructor will want you to reach right here. Your instructor will not want you to, replace ln of c, to further simplify it, to just put it in a compact form. Your instructor may not want you to do that. So whatever way you are required to simplify the differential equation after you have the solution of the differential equation, after you found the solution, you can do that. So I'm just exposing you to a lot of ways we can simplify the general solution of a differential equation. So thanks ever so much for watching. Please subscribe to our channel and see you in our next lecture. Thank you.